So today we'll be doing vector with using vectors to solve geometry, which is this over here, right? The rest we have gone through it already, but I will get down more into it using past paper questions. I may do maybe one or two past paper questions, right? And yeah, so I'll aim for the two. Don't worry, I might even do three if time permits, right? So let's get on to vector diagrams, vector geometry, and topics of sorts. So I'm just going to use the red for now. So I'm pretty sure you're going to like this topic a lot. Excuse my drawing, I hope it comes. Okay, yeah. So let me just put on some arrows. Right, we have an arrow going up here, we have an arrow going so, and let's just say, okay, we have an arrow going so. And let me just put the letters accordingly. Well, this would obviously be A over here. Going up would be B. Next letter will be C. Right, and let's say A to B will be vector 2 and 2. I'm going to show you all why I'm writing these just now. And let's say from B to C it's 5, 1. Right? Now the question will say a vector diagram is given like this, as seen in the question. The vector AB is given as 2 and 2, and the vector BC is given as 5 and 1, right? And the question might be something simple. Find AC, right? So a question like this is just simple. Let's go from A to C. Well, we know A to B has a vector, and we know B to C has another vector, right? So let's use this path and trace it out. So go from A to C, because this is basically saying from vector A to C, right? This is basically going from A, starting off at A, we're going at B. So we're going with the arrows, so that'll be 2 and 2. Plus, right? Because we're going with the arrow, and then we're going from B to C, which is 5, 1, which in this case will be 5 plus 2 is 7, 2 plus 1 is 3. And this is the vector AC. Now let's say, okay, just to go over this one more time, we want to find vector AC, right? So in this case, we go from A to B, and then from B to C. A to B is 2, 2, and B to C is, well, vectors B to C is 5, 1. We add both because we're going with the arrow, and the vector A to C, which will be this vector here, will be 7, 3. Oh, I like this color. But anyways, color is a bit confusing to me. But let's move on. Let's say we want another method, right? Let's call this method 1, right? Let's call this method 2, right? So for AC, this is method 2. We change the color. AC is equal to. So now, sometimes when you're in the exam and let's say the diagram confuses you for whatever reason, or just simply you don't want to use the diagram, or maybe you even want to check your answer over. We know we have vectors A, B, and BC. Now this method isn't entirely correct. I don't know if this method actually is advised, but when I was in my secondary school days, I just used this method to check over what I used to do. And I advise you to use it mostly to check over what you do. So AC, we use the vectors A, B, and BC. Now what I used to tell myself, hey, B and B here used to cancel off, but hear me out. That isn't entirely true. It doesn't work like that, right? I just used to use this when I was in primary school. Sorry, not primary school. Secondary school, when I was writing CSEC, to just check over my work. So I used to say, all right, AB is 2, 2, and BC is 5, 1. So this will be 2 plus 5 is 7, and 2 plus 1 is 3. And there you go. And I used to use that method to check over. But that method really worked for me if I wasn't 100% sure if what I did was correct. I wouldn't advise that unless you want to check over, right? So that's it for the triangle. The parallelogram law, so let me just label this. This was the triangle law, right? This was for vectors, right? So that's the triangle law. You also have to learn the parallelogram law. Yeah, I just had to make sure I said that slowly, right? So I'm moving on, and let me just type that here. That's a B, right? Right, so let's say we're given a parallelogram, right? Let me see how best I can draw this. So this is the parallelogram. Let me label it A, B, C, and D, right? And yeah, so we must go from A to D, well in this case B to A, and B to C, and C to D, right? These vectors here, 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 and here, they are equal, right? So let's give these vectors some names. Let's say from B to A we have 3, 3. Again, the only reason I changed the lettering format is because I didn't want to change these. I wanted to show you all something different. Instead of AB, I showed you all BA. And remember, AB will just be -3, -3. This was the inverse vectors which I showed in the last video, right? Let's say BC is 7, 0. Right? So this is what we have here. This is the only information we have. Just looking at this, we could be able to find AC if they ask us. But let's see what the question is. Let's say we have a question. Find BD. Right? Now we don't have any value here with D. Right? As you all could see here. So, but let's put in what we have. We know B to A is 3, 3. We know B to C here is 7, 0. But also remember I told you all that these vectors here and here are equal. Also these vectors here and here will also be equal. So this will also be 7, 0. And you guessed it, here and here, well, C to D will be 3, 3. So now let's go from B to D. We want to go from B to D, right? Now, what path would you want to use? You can use one of two paths, and you will get the same answer, which I'll show you in a sec. You can either go from B to C, and then from C to D, because that will be B to D, or you can go from B to A, and then from A to D. Let's go the first path I told you all about, using B to C and C to D. So B to C, right, will be 7, 0, right? And then we have C to D, which is 3, 3. So B D will be 7, 0 plus 3, 3, which is 10, 3. And that's it. Now let's see if we went the other method, if we will get the correct answer. That is from B to A and A to D. So B to A will be 3, 3, and A to D will be 7, 0. And that means B to D, right, yeah, will be 3, 3 plus 7, 0, which will give us 10, 3. And as you can see here, the answers are the same, so it's correlating. So that means either method would have worked, right? So just to make it clear, if we want to get from B to D, we can either go from B to A to D or B to C to D. And in both cases, that'll lead us B to D, right? If you don't understand it in your first try, that's okay. You can rewind the video, watch it again, or you can wait till I do the past paper question, in which this will be clarified a bit more. right? And yeah, so let's move on to something else. We just clear the whiteboard. Right. So now with regards to length of a vector. Now I don't see that topic in particular over here with regards to the syllabus objectives, right? But I will still teach you all it because I did see it, however, in a past paper. So the length of a vector, right? This is the formula for the length of a vector. This is how it comes. They might say find this here, and this means simply length of a vector, right? So yeah, so let's get back to it. So the length of a vector, is equal to the square root of x squared, that is the first value, plus y squared. So let's say a question asks like find the length of B7, let's say 7, 9. So the length of, in this case, B, which will be OB, is equal to 7 squared, well, all in under squared, plus 9 squared, which is equal to 49 plus 81, right, all under square root, which will be, let me just put that in the calculator, that will be the square root of 130 units. Now under the CXC exam, when you're practicing past papers and stuff, you can leave your answers like this. However, if you want, you can break it down on your calculator and find it to maybe 2 decimal places, and this is what you should be able to get. Yes, 11.40. And that's it. You just plug it inside the formula and you can go from there. Right? So the next topic will be, we just write here, matrices. All I taught so far for the vectors, which really covered everything here, however, I will go over it again in a past paper question to come, is the basics of vectors. Now, vectors can come ranging from what I taught you to a little bit harder, which I will show you in the past papers. However, the general basics stay as is. Once you know the basics, you would be able to get through. Right? The next topic I will go through is matrices. This is this topic here. And matrices can be a bit interesting because based on what I've seen with the past papers, there was little variation in terms of how the topics of matrices came, right? And once you get down the basics, just like in vectors, you can answer any matrix problems. And matrices can even be done in the calculator. So, but we'll get down into all that in the next video to come. As for now, today's topic was vectors. Once again, this is Prism Caribbean, and I am Jordan Jaffa. Thank you.